Hi there, my name's Willie Bogue, and I'm going to be presenting EHR Safari, which is work done jointly with myself, Mercy Oladipo, and Peter Solovich. So, to motivate this work, we begin with a simple question: how fast does the average heart beat? Because it's a simple question, we could see what the literature already has to say about it, or we could be trying to answer it empirically with our own data set. In this case, we use the MIMIC data set as the case study throughout this work. So the literature says that the average heart beats around 80 times per minute, and that makes sense. But when we try to look at our own data set to see what it empirically says, we see that there's this unexpected bimodal distribution where it also has the peak at 80 beats per minute, but it has an additional peak around 180 beats per minute, or about 3 times a second. And when we try to understand why that is, something unexpected arises. By plotting heart rate versus age, we start to see the answer. So we can see here in the green that the unexpected second bump was coming from newborn babies in the neonatal ICU who just have very different physiology from adults, and their heart is beating a lot faster. But while we're also looking here at this heart rate versus age plot, we see there's another unexpected thing happening, and that there's a lot of patients who seem to be 300 years old, and this is a result of the de-identification process. Because patients who are 90 years or older would be too easy to single out otherwise, they all get grouped together as having uh, an age of 300 years old. And so this goes to show that there are strange quirks in a new data set that you might be exploring, such that if you don't know how to navigate it properly, you might not be able to answer your questions correctly or meaningfully. And that's what this paper is about. It is a case study looking at a series of quirks in the MIMIC database, using MIMIC as an example, but it's true for all kinds of healthcare data sets out there, of unexpected or unintuitive things that occur. And then we identify multiple published works which make incorrect modeling assumptions. In this presentation, we'll give a brief highlight of a few of these example quirks in the dataset, and we encourage you to read the full paper and to talk to us. You'll learn lessons learned, such as how to avoid accidentally quintuple counting the symptoms in your language model derived from patient notes, and about the importance of talking to someone who understands the quality of labels and can walk you through them to make sure that they're correct, so as to avoid potentially exacerbating racial biases. The main purpose of this project is to really underlie the importance of working collaboratively with someone who understands the data generating process. Thank you very much.